Welcome to NSTA Podcast. In this segment, Sarah Michaels will talk about what's common among the standards for science, math, and ELA.
So what's common? All of the standards, math, ELA, and science, require that teachers focus more attention on core disciplinary practices. Ted sort of talked about this. These are intellectual practices that are central to each discipline. And as Ted said, for anyone who's been attending these webinars, you have already heard quite a bit about them. You may have even memorized this list of 8. So here are the science and engineering practices. I'm not going to read through them. You've already seen them. But I'll give you just a minute to look over them. And here are the mathematical practices. These are a little bit different. They're framed a little bit differently. Make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics. There's some resonances across these. Use appropriate tools strategically, attend to precision, look for and make use of structure, look for and express regularity in repeated reasoning. And here are the ELA. Okay, so instead of practices, the ELA standards identify what they talk about. You can't see it very well. Capacities of the literate individual. This is actually page 7 from the Common Core State Standards for English Language Arts and Literacy. The literate individual builds strong content knowledge, just listing them, some of them. The literate individual values evidence, comprehends as well as critiques. So here's a listing of all of these practices, the key intellectual practices in math, science, and ELA. They're all different, as you would expect. But there are some striking commonalities, and so I want to take a look at some of the shared elements across the standards documents. And in some cases, they're pretty much identical. Okay, so take a look at math practice number 3, construct viable arguments and critique the reasoning of others, and science and engineering practice number 7, engaging in argument from evidence. And a few more of these practices seem to relate explicitly to sense-making and discussion, reasoning, in the service of arguments and explanations. So I want to take a look at where we can see discursive or talk-related or discussion-related elements, okay? So here in the math practices, all of these in red relate at some level to making sense, talk, critiquing reasoning, expressing reasoning, making arguments, and so on. And similarly in science, there are a number of what we might think of as discursive practices that relate to talk or discussion or communicating one's ideas. So what about ELA? Okay, are the same discursive practices common here as well? So as I said, the ELA standards emphasize the capacities of literate individuals and key processes of communication. And if you read the small print, what I've got in yellow there, if you read the small print, here in the ELA standards, you see that they're in many cases word for word the same as in the mathematics and science documents. So you get construct effective arguments, or assess the soundness of reasoning, cite specific evidence, worry about the validity of reasoning, relevancy and sufficiency of the evidence. So from a separate listing of these practices, you can see that at the core of the Common Core and Next Generation Science Standards is what I would say building arguments with evidence and reasoning. And this, I want to give a little shout out to Tina Chuk and Oki Lee. This Venn diagram, you guys can take it. It's a very slight adaptation of one they developed. These are folks at the Understanding Language Project at Stanford University. And I think it really helps you see what's at the core of the core. And so what is at the core is reasoning with evidence, building arguments and critiquing the arguments of others, and participating in reasoning-oriented practices with others. But I want to take a deeper look at the practices that have been identified, okay, even the ones that don't mention anything at all having to do with talk or discussion or argument. So, for example, if we look at practices 2 and 3 from science, developing and using models, or planning and carrying out investigations, or if we look at practices 4 and 5 in math, model with mathematics, use appropriate tools strategically. So in order to learn how to model or analyze data or use appropriate tools, kids have to participate in these practices with others, and it's primarily through talk that this happens. These high-level thinking practices, every single one of them, require that students participate in making their thinking public and cogent. And for this to happen, teachers are going to have to find ways to help all students, and I'm talking about English language learners and language minority students, struggling students, kids on IEPs, all students, go public with their ideas. They're going to have to help students externalize their thinking, listen carefully to one another, and actually really take one another seriously. They're going to have to help all kids dig deeper into the data and evidence and models for their positions, and they're going to have to help kids work with or attend to or engage with the reasoning of others. They're going to have to build a classroom culture where students think with each other, construct arguments with data and models, critique the thinking of their peers, and make progress collectively on important problems. And these reasoning practices have to be enacted. And for learners, most are enacted socially, in the beginning at least, through talk and writing. So in order to participate in these thinking practices, you have to be enacted into them socially. And by social here, I'm not just talking about student-led group work. This is really important. Well-structured social interaction, well-guided talk, builds in time to think as an individual, time for productive struggle, with scaffolded support for new ways with words, new ways of representing ideas and modeling, making thinking public and available to each and every learner. So in my view, we're going to have to shift our view of what's at the core, what's common across these standards, and see that really what's common to the Common Core and Next Generation Science Standards is actually building classroom cultures that support public reasoning, making thinking visible and available. And so teacher-guided discussion, productive talk, is going to have to become the new normal, really the grounding for all of the practices. So here's my bottom line. Because these thinking practices are inextricably linked to content and to core ideas, participating in talk is not an add-on. It's really going to turn out to be fundamental to the learning goals in each set of standards. And so from my point of view, what's common is more than a few key practices at that very center of the Venn diagram. Well-guided, scaffolded reasoning, talk, and discussion is going to have to become the new foundation, the new bottom, the new sort of norm, basically, for all of the practices in the Common Core and Next Generation Science Standards. And in my view, this is not going to be trivial. If we're serious about promoting the thinking practices at the heart of each of these standards, we're really going to need a huge change, a dramatic change. I think of it sort of as a sea change in terms of the kind of talk that teachers facilitate. And here the research is really clear. And this is the bad news part of my talk. This kind of discussion is not happening in most classrooms, even in ELA classrooms. So while there's a lot of talk going on, it's often not productive talk. We know, for example, from Donna Alverman's work, that many teachers say and actually think they're doing discussion when they're not. And in Appleby's large-scale study of middle and secondary classrooms, he and his colleagues found that there's an average of less than 2 minutes of discussion per hour in most ELA and social studies classrooms. And what little there was consistently in high-tracked classrooms, leaving out a lot of kids. So it turns out, while there's lots and lots of talk in classrooms, there's actually very little well-guided discussion happening at any level, at any grade level, in any subject area in the country. Instead, teachers rely on what we might think of as recitation and a few reliable talkers. Most of the so-called group discussion is actually more like group recitation, and that's where, the teacher asks a question. It's usually a question that has one right answer that the teacher is looking for. A student responds, usually with a pretty short answer, and then the teacher evaluates, like, good, right, or not quite. Anyone else have an idea? And then eventually the teacher gets the right answer and then goes on to another question. And people call this very familiar sequence the IRE, initiation, response, evaluation. Teacher initiates, typically, student responds, and the teacher evaluates. Now, I want to be clear, there's nothing fundamentally wrong with the IRE. In fact, it's actually a really good way to review or check or quiz the kids about what they recall from an earlier lesson. But here's the bad news. This IRE, or recitation and direct instruction, really the dominant forms of talk that you find, do not support reasoning. They don't support the building of arguments with evidence, and they do not support students to do the heavy lifting of explaining or critiquing or building common ground with one another. In the IRE, the students are positioned kind of as getting the right answer or the wrong answer. They're not doing the heavy lifting. They're not positioned as thinkers and as builders of arguments who weigh evidence and so on. And so, as I said at the outset, the challenge facing the country now with the Common Core and Next Generation Science Standards is to shift from recitation to reasoning-based discussion.